All right, so what I'm gonna do is I'm gonna try to help you figure out how to memorize these polyatomic ions. My trick that I have is not gonna cover all of them, but it should cover most of them. It's gonna cover our eights. So we're gonna talk about memorizing the eights. So we're gonna talk about nitrate right here. We're gonna talk about chlorate, and then we're gonna talk about carbonate, sulfate, chromate, and phosphate. Okay, so this little trick will help you memorize most of these eights, and then I'm gonna talk about how we go from 8 to 8, and then adding prefixes, things like that. So if we can get the foundation of the eights, this will help you out a lot. Okay, so what I'm gonna do is I'm gonna flip to the back side, and we're gonna write down a sentence that the chemistry team uses quite a bit to help you memorize it. So kind of bear with the sentence. It doesn't make a lot of sense, but once you get it down, it does actually help quite a bit. Okay, so let me switch over my ink real quick. All right, so the sentence we're gonna write is, we're gonna write Nick. So I'm gonna do all capital letters for certain words, and you'll see why in just a second. So we're gonna say Nick, so N-I-C-K, the camel. So camel is all capital letters, C-A-M-E-L. 8, a clam, and clam is all capitalized. And crepes. So crepes is all capitalized, C-R-E-P-E-S. 4, supper, and supper is all capitalized. In Phoenix, and Phoenix is all capitalized. So make sure you know how to spell Phoenix, otherwise this trick doesn't really work out for you. Okay, so now what I'm gonna do is I'm gonna show you why these matter. Okay, so I'm gonna break down what we're going to do for our vowels and our consonants and how that actually makes sense to memorize these polyatomics. Okay, so if we go back up here, we're going to look at nitrate. So nitrate right here is NO3 with a -1. Okay, so this one right here. So we're going to come back down here. So Nick, I'm going to write Nick is right here. I'm going to write it down here. Nick equals nitrate. So NN. Okay, so now what we're going to do is I'm going to take a different color. And here's your trick, is that we know it's going to start with N. Okay, it's going to be NO. Okay, so I'm going to write that down. Let me go back to my other color. So NO. Now I'm going to go back to my other color. So my consonants are going to tell me how many oxygens I have. Okay, so I have 3 consonants in Nick. So consonants is anything but a vowel. Okay, so I'm going to write this in the same color right here. So consonants. If I can spell it real quick. So consonants equals your numbers of oxygens, your number of oxygens. Okay, so if I have 3 consonants in Nick, that means I have 3 oxygens. Okay, so that actually helps you remember how many oxygens there are. Now I'm going to switch to a different color. Okay, and your vowels are going to tell you the charge. Okay, so I'm going to do my vowels equals the charge. Okay, so what I mean by the charge is the little positive or negative up in the top right-hand corner. Now, most of your polyatomics are going to be negative, so you don't really have to work besides one, and we'll talk about that one here in a second. Okay, but they're all going to be negative, and if I have one vowel, that means I have a -1 charge. Okay, so now we're going to do the next one. So I'm going to go back to my color. So we're going to look at camel. So I'm going to write down camel. Okay, and camel, just the C by itself, that is actually going to be carbonate. Okay, so carbonate. I'm going to write that down. So carbonate. And that is CO. Say carbon and oxygen. Okay, so I'm going to switch my colors again. So I'm going to look at my consonants. I have 1, 2, 3 consonants, so that is 3 oxygens. And I'm going to switch back to my green. Okay, and I have 1, 2 vowels, so that is going to be a -2 charge. Okay, now we're going to look at clam. So I'm going to write down clam. Now clam has that Cl, so that's kind of a hint that we're actually going to be dealing with chlorate. So that's chlorine and oxygen. Okay, so I'm going to write ClO. Okay, let me switch my colors. So I have 1, 2, 3 consonants, so that's 3 oxygens. And I have 1 vowel, so that's a -1 charge. Okay, so now we're going to do crepes. So I'm going to write down crepes right here. Now that CR, okay, that's going to tell me that's chromate. So I know there's an H before the R, but that does kind of help out. Is chromate is going to be CRO. Okay, so now we're going to switch my colors. I have 1, 2, 3, 4 consonants, so that's CrO4. And then I'm going to count my vowels. I have 1, 2, so that's a -2 charge. Okay, just a couple left. We have supper is next. Okay, and supper is going to be sulfate. So that's SO, so sulfur and oxygen. Okay, let's switch my colors. So I have 1, 2, 3, 4 consonants, so that's SO4. And let's go back and do our vowels. That is going to be 1, 2 vowels, so that's a -2 charge. Okay, last one is phoenix. So remember, make sure you got the spelling for phoenix down right, otherwise this won't make a whole lot of sense or won't help you out much. Okay, so switch colors. Now if I go to phoenix, I have 1, 2, 3, 4 consonants, so that's going to be, oh, forgot to write down my elements. Phoenix is going to be phosphate, so that's phosphorus and oxygen, so PO. Now I'll go back to my colors. I have 4 consonants, that's PO4. And now we'll do our vowels. I have 1, 2, 3, so that's going to be PO4 with a -3 charge. Okay, so this, you'd be surprised in how much this actually helps with most of the polyatomics that you're going to be learning. Okay, because if you can get these main 8s down, I'm going to show you how this is going to help with something like this. Okay, so let's take a look at chlorate. Okay, so chlorate we know is, so if you just did your chlorate, so you go back to your sentence, so Nick the camel ate a clam, so clam would be ClO, so chlorate, ClO. And there are 3 consonants, so that's going to be a 3 down here, and there's only 1 vowel, so that's going to be a -1 up here. Okay, so now that is chlorate. Now if you look, we have chlorate, we have perchlorate, we have chlorite, and hypochlorite. Okay, so I'm going to show you how we switch those names up, and if you know this main base right here of chlorate, then it becomes a lot more simple. Okay, so when you add per to the beginning, okay, that means you add oxygen. Okay, so that perchlorate becomes, so I'm going to show you, perchlorate becomes ClO4 with a -1. Not changing my charge, okay, so you're just adding an oxygen. So per means you add an oxygen. Now if you go to from chlorate to chlorite, okay, so I'm going to write down chlorite right here. When you go from 8 to ite, that means you lost an oxygen. Okay, so instead of ClO3, this now becomes ClO2 with a -1 charge. Okay, and then lastly, if you see hypochlorite, okay, so I'm going to write it here, so hypochlorite. Okay, that means you take away 2 oxygens. The way I remember that is there's a term, if you don't know, it's called hypoglycemia. It means low blood sugar. Okay, so that means you're just getting too low. So when you add hypo, that means you're getting you're too low, so you took away 2 oxygens. Okay, so that becomes ClO. Okay, so there's only 1 oxygen now, and it's still a -1 charge. Okay, so if you know chlorate, so up here, if you know that ClO3, then all you have to do is, if you add per to it, you add an oxygen. If you go from 8 to ite, you take away an oxygen. And if you add hypo and you're still ite, that means you took away 2 oxygens. Okay, so this actually helps out with quite a bit. Okay, so if you know your base, like that sentence we just did, that would help out with nitrate, it would help out with nitrite, it would help out with perchlorate, chlorate, chlorite, hypochlorite. It will help out with carbonate, sulfate, sulfite, chromate, phosphate, and phosphite. So just knowing that sentence is going to help you with the bulk of these polyatomic ions. And these 8s are what we use quite a bit. Okay, so there are some things we'll talk about just a little bit. There's some that are different. Okay, and I'll try to do my best to kind of clarify that. So if we look at something like carbonate, so right here, okay, it goes to bicarbonate. Okay, so some of these things you just kind of have to kind of figure out a way to memorize on your own. Okay, bicarbonate, that just means we add an hydrogen to it. Okay, and once we add that hydrogen, you actually see your charge goes to a -1. Now, if you look on the periodic table, hydrogen has a charge of a +1. Okay, so since I'm adding something with a +1, it makes sense that my -2 right here would jump down to a -1. Okay, then another one that doesn't really follow the naming pattern would be dichromate. Okay, so right here. Only thing I can really help to memorize that is di. The prefix di means 2. So when you go from chromate to dichromate, now you have 2 chromates, but then your oxygen jumps up to 7. Okay, so I just remember that as it doesn't, the chromates double, but the oxygens just don't quite double. It just goes up to 7 instead of 8. Okay, but your charges still stay the same. Okay, so for the most part, that sentence really does help out with the base of this, and we use nitrate, chlorate, carbonate, sulfate, phosphate quite a bit in this course. So those are your main ones that we care about. Now you have things like ammonium over here. So ammonium is NH4 with a +1 charge. It is the only one that has a +1 charge. Okay, so this is another one that you just kind of have to get down. So ammonium is always going to be NH4 with a +1 charge. Okay, then you get some different ones. You have acetate. This is probably the biggest one. Okay, so acetate right here. Okay, that is going to be C2H3O2 with a -1 charge. Okay, so you can see we keep these things in parentheses because we cannot interfere with those. And that's going to make a lot more sense when we start doing all the naming and we start writing out the formulas, is if it's in a parentheses, you cannot alter it at all. So acetate will always be C2H3O2. Chlorate will always be ClO3. You cannot alter those whenever we're writing formulas. Okay, so the way I remember acetate is I just remember CHO, so CHO, and it just goes 232. So CHO 232. Whatever you need to do to basically help you memorize that one, whatever, that's fine with me. And then you have cyanide. Cyanide's not too bad because cyanide, it looks like it's CN with a -1 charge. It almost looks like cyanide abbreviated. Okay, so cyanide is just CN, carbon and nitrogen with a -1 charge. And then lastly, you have hydroxide. The way I think of hydroxide up here is almost like hydroxide abbreviated, but just backwards. So instead of HO, it would be OH with a -1 charge. Okay, so if you get this sentence down right here, so Nick the camel ate a clam and crepes for supper in Phoenix, and you know how to break down the vowels and the consonants, okay, this will make your life a lot easier because I still use this sentence even whenever I'm thinking of these polyatomic ions. And then just make sure you know your naming. So remember, if you add per to it, you're adding an oxygen. And if you go from 8 to ite, you took away an oxygen. And then hypochlorite means you took away 2 oxygens. Okay, so if you go back up here, if you look at phosphate, phosphate is PO4 with a -3. So phosphate right here. It's PO4 with a -3. And when you go from phosphate to phosphite, you went from PO4 to PO3. So you see how you lost an oxygen? So it does not matter how many oxygens you start with. Okay, so if you notice chlorate has ClO3 and chlorite goes to ClO2. Okay, phosphate is PO4 and phosphite is PO3. So it doesn't matter how many oxygens you start with. It just matters if you take away an oxygen, you're going to go from 8 to ite. And that's probably one of the #1 mistakes we see is the difference between phosphate and phosphite, and then phosphide, which we'll talk about here in a little bit. So hopefully that kind of helped you memorize these polyatomics.